Okay, my friends, get ready for this. The reason I am doing this is because I am having an ongoing dispute with Don Lincoln, the one that put up these articles about these point particles. And we're sort of going head to head here, actually since almost this time, because I showed him these particles, I think it was 2014, 2015. He told me I was a tinfoil hat guy, don't ever get a hold of him again. And I stayed away. I'm pretty fed up with that. He's spending our money like water. This is Fermilab. He just got another, I think, $260 million or something, some special deal. I mean, it is spending this goes almost 10 years. It's got to be into the billions of dollars at least that we would have saved by looking at what I had to show instead of wasting our time doing this silly stuff. We already found the particles. I'm going to show them to you right now. And this is what annoys me. And I don't want to be nasty to Don. He seems to be a fairly reasonable guy. Only he's just to miss what he's missing. I hate to say it, but he's either incompetent or he's got some other alternative motive. You can't be a competent scientist and just ignore this and say, I am going to ignore you. He told me, so I'm going to ignore you. Just do anything you want. I don't care. I'm going to ignore you. I'm not going to pay any attention to you. And exactly what he's told me. So forget about it. You have any right to say anything you want, but who cares? Because I'm not going to pay any attention to you. Now, these are the particles that he found, and these are the particles we found too. Only he's spending billions of dollars and we're spending peanuts. So that's why he's spending your money. You understand me? If you're in the United States, he is spending your money in handfuls and gobs. And that's all they do is look for funding. So the more circles they can walk around in, the more funding they get. And that's why, as far as I'm concerned, that's the only reason he won't pay any attention to this. And he thinks he can get away with it. And I'm not going to let it happen. And I'm going to ask for a congressional investigation if this doesn't get talked about. This is our future. This is possible energy for free. And it's been denied by the people we put in charge and gave them tons of money and said, please do this. And they don't care about doing it as far as I'm concerned. This is not for us. If this is his attitude, and it is, absolute denial and never once addressed one of my questions, not even ever once addressed any one of my questions about how much does light weigh? What is light made out of? What is no. And he's got every one of these things at the very bottom. He puts in, I got a question, get a hold of me. Yeah, I want a phrase defined. I have a question. Yeah, I did. Don't ever call me again. And this is exactly what I showed in a summary. The extended particles have a fixed size. That's the black one. It never changes. And it has a fuzzy edge around it, which is the glowy edge. Yes, no question. Point-like particles are mathematical right. Zero size. Yes. And I show this in atomic bomb blast. I can show everything that I'm talking about and support every word I say. And I'm going to tell you right now, that's muon neutrino, electron neutrino, the black and a white ball, turning into a sterile muon, an electron shower. There it is, my friends. There it is, my friends. And this is Don Lincoln's particles. These are our particles. And for him to deny to even look at this, he absolutely refuses to discuss a single word I say. And I say, this is your obligation. It's your fiduciary duty. We put you in charge to try to help us. And you all you're doing is trying to help yourself. Don, I'm not impressed, my friend. All right, so why am I upset? Well, right here, this is Lawrence Livermore. I'm going to show you this in a second. Remember I showed you our Venturi. The laser just sends out its pulses and the Venturi restricts it, and all we get is the white coming through. The white is the electron showers. Now let me show you this. Now this could fit into one of these little devices. This is just a Geiger counter, but something similar to this. Just carried around in a little box like that. You could probably run a car, because you could have thousands and thousands of these inside this. All solid state, sealed up. No, it couldn't hurt you. And it's not putting out anything other than that white energy, which has no weight whatsoever. And these are what's called electron showers. Now I just showed you electron showers. These are low energy electron showers. These are high energy electron showers. These are the electrons. You see it? Electron showers, high energy. That means they increase in energy from low energy. And I showed you that right here. From low energy to high energy. These are the electron showers. Exactly what it says right here. Electron neutrino turns into electron showers. That was the white one. It was attached to the black one. The black one is now on its own called a sterile neutrino, a sterile muon. And it can't get any more clear than that. It can't possibly get any clearer than that. And for him to have found these particles 10 years ago, more than that, and then just to say, no, I'm not going to listen to you because he's just not going to listen because I'm a tinfoil hat guy. And he told me, just I've been fighting with him for the last couple of days. He's, yeah, you're embarrassing. You're something about me being embarrassing. Well, he's not a scientist. He's incompetent, and he's just spending our money like water. You know, Don, I'm sorry. It's your fault, my friend. It's not my fault. It's your fault. All right? You see that? That's the muon, the black ball. It doesn't go through. It stays back out here. Exactly what Lawrence Livermore fought. The same thing. They got the exact same deal. The muon, the black ball, stays out here. It doesn't go through. The white showers through and creates high energy. And it's separated, so the energy is staggeringly high. You see this? The white one goes through and creates the high showers. The black one, the muon, comes here and bangs off, and it stays out this side. There's no difference. Now, this is Lawrence Livermore. This is another government agency. I sent them all my stuff, too. And they're doing something now, phaser. I think it's Lawrence Livermore doing a phaser. It's just nothing more than banging a particle. And then at the other end of a bunch of tungsten, I think they're using, another particle comes out the other side. It's like that one of those Newton's cradles. I'll show you in a minute. They were spending our money for thousands of people, millions and millions and millions of dollars, and setting up all these projects. They've already found the particles. And the protons are made out of dipole electrons. Let's get past this. The standard model doesn't even predict gravity. They have no idea why things fall to the ground. None. The dipole electron theory solves the whole thing. They don't understand global warming. Way out at the edge of the atmosphere is thousands of degrees. Why? They have no idea why that happens. Thousands out there. Should be cold. No, thousands. And so on the same thing with the sun. The sun is 10,000 on the surface, millions way out away. They have no idea about that too. They're going to spend billions of dollars to try to figure that out. All it is we're scrubbing through space. Our atmosphere scrubs through the atmosphere of space, which is saturated. It's not a vacuum. There is no vacuum out there in space. They know this. This is what annoys me. They should know, even a 10-year-old should know this. And they will know this. And they're going to look at these people with disgrace for doing what they're doing. All they're trying to do is keep funding and making up silly concoctions to get more funding. That's all I can see, because not a single one of them I found is interested in the truth. Right across the board. It's all about funding, and it's all about containing their grasp over the kids and their status and their money. And it's all related to peer review. It's just like racketeering. They say, we won't let you speak unless you say what we tell you to say. And that's exactly what it is. You can't peer review. And peer review means that we won't let you do it unless everybody else says you can do it. And nobody else will let you do it, because if they let you do it, they'll be destroyed too. It's just exactly like peer review. Like they'll break your legs if you try to get into their realm. Racketeers. Now, this is not big money here to test this out. All they got to do is send some, get a few people, get some engineers, engineer a few different types of venturis, send different types of lasers through the venturis, and get a solar cell, some type of harvester on this side. Because all you're doing is send it into just like a solar panel. It's going to absorb it just like basically a solar panel. But, there's a little technical stuff here, but not much. We could see what I thought was pretty obvious, that there was a very big increase in energy. Anytime you see an increase in luminosity, that means an increase in energy. And that, my friends, is an increase in luminosity. That is on steroids, luminosity. All right? And we can see we're pushing the particles with the black. everything adds up. Electron dipole, electron flood theory is what works, and it should be looked at, and it's refused. And this is what I have found out 100% in academia. They absolutely refuse to engage in anything that it doesn't matter if it's true or not, doesn't matter how much evidence you have, doesn't matter what you present. They're destroyers, and like I told Don, I said, Don, you're not a scientist. You're a deniantist. No science there. It's a deniance. And Fermilab should be, it's a disgrace to let somebody like that spend our money like water and not paying attention to anything that is so completely obvious that there is no level of incompetence that could miss this. You can't be that incompetent. It's impossible. So what is his motivation for just denying this? And I'm going to ignore you. I won't talk to you. And I told him, I said, I'm going to ask for a congressional investigation against you, my friend, because you're spending our money. You couldn't care less. He says, oh, I think I can withstand a challenge. I said, well, let's find out. All right, and I want this checked into. We're spending money. This is our money, my friends, and we don't have a whole lot of extra money right now. And the whole thing of this science funding is just ridiculous. Absolutely ridiculous, because they don't care about the truth. It's nothing but making up concocted stories to get more cash. Oh, my friends, this blows my mind. Every time I do something, it gets more and more complicated. They're talking about, can light act as both a wave and a particle? It is a particle, and it has a field around it, so it creates a wave. However, think about this. All right, this is a mind blower. It doesn't have to be both. I say it's both because the particle makes a wave. However, when we put it through the accelerator, through the Venturi, we separated the white part from the actual particle, which is the black part. This is mind blowing. Oh, okay, get your atomic physics hat on, because we're going to do some atomic physics now. How much do electrons weigh, and what are electrons, and do electrons make up anything, or are they just electricity, or what's the story with electrons? Well, they do have a mass, and in my electron flood theory, dipole electron flood theory, everything is made of these two particles. There's a black one and a glowy one. And the black ones go right to the center, and the glowy ones surround them. But they're the only two that make up everything there is. A white particle and a black particle. And as they accumulate, they surround the black, and the black goes to the center. Now, and there's several different styles of things going on. There's the two separate ones, and they can go on their own, which we have separated them. So the black can completely separate from the white. Or they can stick together, and they really, really, really want to be stuck together. To get them to go apart from each other, very, very hard. That's called generating electricity, because that's the electricity. You're ripping it away from the black. That's creating electricity. If we could rip that away from that black, we create electricity. It's as simple as that. Now, the two of them together are what you would always call an electron. Well, an electron is not really what they thought an electron is. An electron is, in the old thinking, it was just this little minus particle. They said it has no weight, and they say actually photons have no weight because they don't know about the dark particles. Something's pushing that photon. The photon has to have some weight. It's going moving through the air, and this is the weight that's pushing it. These are called the carrier bosons. Now, so the two of them together make an electron. Well, what is an electron? An electron is a dipole, which means it has a positive and a negative, which means it has a field, a little bit of a field around here, just around this side. And what does it want to do? It wants to either glue into something, because it's got a field that wants to attach to something. It wants to glue into something, or it wants to float around as heat. That's what these are, is heat. When you take a rock, let's say I took this rock right here, and it weighs a pound. And if I made it real hot, it would weigh a pound and a gram, because it's going to gain weight from being hot. And I said, well, why would that happen? more electrons flow in there, and that's what heat is just excess electrons. It's packed with electrons now, and it's now 100 degrees. So I forced electrons in there. It's 100 degrees, and I bring it into a 70-degree room, and it leads those electrons to go back to where somebody else will want them more than this, because this wants to get rid of them. It's too hot, and this will take them because it's cold. That's what the transfer of heat is. And it's transferring both of these together. Now, what is electricity? What is electricity? It's not this whole thing going. This is heat, and it's called a gluon. Now, electricity is just the weight. And electricity has no weight whatsoever. It's just, it doesn't weigh anything. If you took a car and it weighed 4,000 pounds, and you filled, and it was completely empty with electricity, totally empty, it's 4,000 pounds. You filled that up, it was full as much as you could put in there, and it still weighs 4,000 pounds. You drive it all day and you go 500 miles, and it still weighs 4,000. It never changes. No matter how much electricity you put in or take out, no change. In a car, to get that energy, a 10-gallon tank weighs 60 pounds. Right? The gasoline weighs 60 pounds just for 10 gallons. And in an electric car, there's no weight at all, because all you have is this. This is chasing through all of the circuitry in there to get to the black. That's the key. You got to separate them and get the black over in one area, waiting for the white. And the white will go through anything to get to it. That's why you got electricity, lightning, static, right to ground, go right through trees, right through you, anywhere. Because it wants to get to ground. Ground is the black. Ground is saturated with dark particles. Right? That's why it's ground. It always, the electricity, which we always thought was just a white. It's not. It's both. But they both go to ground. Now, if there's strictly only white, they will just force their way through everything else to get to ground, depending upon the potential. The potential means how much is out there. Let's say there's 10,000 gallons of this white here. Just think of it as liquid. And there's 10,000 gallons. Well, it's going to get to the ground. If there's a couple of drops, well, so it depends on the amount of particles all together at one time in one area. That's why you have lightning, and that's because of the scrub of the particles in the air against the water molecules primarily, because the water is H2O. Well, that's hydrogen and oxygen. And there's two hydrogens and an oxygen, and when they start scrubbing all together, you get electricity, and that's why you get a lot of lightning when you have storms. Now, here's the deal with these particles, and this is as simple as this. And I'm telling you, this is simple. You should very, very easily understand this. I showed you the white. All right, it has no weight whatsoever. I showed you the black. It has all the weight. This has all the energy, this has all the weight. This will push through anything to get to that, and it will burn anything to get to that, and I will show you that in a minute. Burning, and then the black comes. Now, so this is what's unknown. They never knew this black existed. That's dark matter. Nobody's ever known it was there. They always thought the glowy one was the only thing that was there, and photons had no mass because there was only these little glowy things, which I agree. The glowy things have no mass, but they're only being moved because the black ones are moving them. And I can show you this. This is, you know what? Let me show you that first, and then we'll get to this because it'll make more sense. When I say I can prove things, I can prove things. I'm not just talking out of my hat here. You see this right here? These are the particles, and they know this at Fermilab. These are actually the pictures from Fermilab that they show of the particles that we found. And here they are right here, and they do exactly identical what Fermilab says. This has all the mass, and it never changes size. This can get small and big, just as you can see, and it has all the energy, and it has a fuzzy edge around it. You see it? This is from Fermilab. This is not my particles. It's from Fermilab. And this one is the point particle. Now, the point particle, they claim, has no weight at all. And I have to agree. It's an abstraction, they say. I can't find any fault with that, to be perfectly honest with you. I find it very difficult to believe something that is nothing has energy. So I'm sort of thinking it's got to be almost like a soap film bubble or something that just gets crazy big, but stretches out somehow so it gets tiny, 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 thin. I don't know. I just can't understand it, because I know, as I said probably already, about the car. It does not gain any weight. Where's that electricity energy coming from? What causes that? We know that the white has to get back to the black through whatever circuitry, and that's what causes the motors to drive and heat up and all that stuff, is because of that white stuff is going through to get to the black. That is not, I mean, that's absolutely certain. So how could it have not any weight? That's the key. I can't understand it. Now, this shows that these are the particles of Fermilab and CERN. See, the smallest particles I've ever seen. There they are. And here they are right here. But they're light. They're twice as big as these. Now, they see them mostly separated, but then they see them together. They call them Dirac neutrinos, which are stuck together. And that's what this is right here, gluons, Dirac neutrinos. And so one side stuck to the other, like two bar magnets, makes a photon. A photon has a field surrounding the whole photon, so that when it goes through the air, it creates this big wave-looking thing. But the particle's inside the wave, but everything's got to get out of the way, and I can show you that too right now. And then don't forget, when we put it through the Venturi, it separated the black from the white. I'll show you that in close detail too. All right, what I'm going to show you here is photons. Now, you see, these are all pictures of red light being accelerated, and we're going to see the photons, we're going to see acceleration, we're going to see how they push and all that. Let's start with the photons. You see those black particles and white particles there? You see that? That's a photon. And they charge up as they come closer and closer to the impact zone. So out here, they're what they call neutrinos. They're charging. They're what they call flavors. They get more and more charge to them. So that one there is flat this way, and then they turn sideways. I don't know why. And the one exactly straight in line with the Venturi, though, is a different story. That one is coming and it's compressing against itself. It's pushing back. So this thing here right now, that photon thinks it just hit a wall. That's why you can see it right in the middle of nowhere land. It's absolutely fabulous. Otherwise, you wouldn't see it until it actually hit the wall. But because there's so much pushback to it, it actually illuminates out there as a full-fledged photon. That, I think, is unusual. And the same thing happened with the green. You see how perfectly configured that is? Black and white on two sides. You know, it's like two bar magnets. Think of it that way. And you see it? A little spike going up, spike going down. And it's all glowed up here because it would have just got smacked right into the Venturi right here. And this is the pushback. Right. Now that's why the only one that really is glowing is the one coming straight down the center. Up in here, they're all over the place up here, but you don't see them until they get up here. And then all you see is like these things. When I show you this other one, you'll see all of the particles are up in here, and they only see on a very leading edge of them. You see it in a second. Now, what do we use for equipment to see this? Where do you see this? All right, this is what was used. Exactly this equipment right here. A Bosch GLM-15 laser, which is a construction laser. Now, Rodney had the metric ones, same thing. They just different program in there, convert to metric. This is a Samsung Galaxy S3. This goes back to, I think, 2012 or 13, somewhere around there. And he started taking pictures of trying to do a double slit experiment. And instead of using a flat plate, he used nails, literally round nails. And he shined his laser in between the nails with very, very close, and it came out with this. That's through nails. This is all it is through nails, and then taking from what he tells me. Now, he did virtually all the camera shots Well, we had a couple other people, but nothing like Rodney. Rodney did 99% of it. I did virtually none of it. Very small amount. And I'm not capable, and I'm not going to do it. Somebody else can do it. All you have to do is create this little tiny slit. But it's got to somehow pinch together. And when these fields come in, they're big fields. But when they have to hit that slit, they're squished in like this, and they come out the other side just stunningly fabulous amount of energy. Okay, I'm going to turn the lights back off so you can see the shots better. But you saw the red, how it's building up energy, and then until it's full-fledged photon. And then it actually split. The black separated from the white because the black couldn't get through the slit. And here it is. If you looked at it from further away, here's what it looked like. It started out just as a regular wave, and then it started to accelerate, and you can see that it's pulling itself right out of its own wave. That's the magnetism. That's the field, which they call a wave. The particle is there. It's quite obvious what you got here. There's the wave, which is coming through the air. Is it a wave or a particle? The particle is inside the wave. And it's a big magnetic field. And now it's being pulled right out of the wave, and it's on its own here. And right here is where the pushback comes, and it illuminated as a photon. And then you see over here, here. All of those are photons that were in the air as well. You just never saw them because they weren't concussing anything yet. When they had hit a wall, then they would concuss. To them, this is a wall. This is literally, and I'm not kidding you, I mean this with every bit of it. This is a subatomic nuclear explosion. This is in the subatomic realm. It's light, which is smaller than atoms, subatomic, and the black has separated from the white and exploded. And then it come back together. So this is also fission, and that's fusion. All right, everything is right here, right in front of you. Everything, physics in a nutshell. Dark matter, dark energy, fission, fusion, sterile muons, electron showers. It's all there. Photons, and we can see the photon wobble. We can see the muons, electron neutrinos. There's nothing I can't show you here, and it's all got to do with dipole electron flood theory. And once again, this was all just basically an accident. Rodney was trying to do a double slit experiment when he started showing the pictures of, I don't know why, he was just showing pictures, and people were thinking he was kind of crazy for showing these crazy pictures. I knew what he did. I said, wow, you just did something that nobody in the whole world's ever done before. And, he was excited about it. He worked with me literally for years. And nobody would pay any attention. And eventually, I have never heard from him for several years now. And I don't know what happened to him. I hope he's all right. But, you can only take so much of being, and I know he had some trouble with other things. His people didn't accept him at all for seeing what he sees here. No. And that's what happens. Now, these are all fields in the air. Well, what are they fields from? Why would they have fields all in this air here and glow like that? Those are gases primarily. Now, I don't think he shot any water mist into here, but you could do that. I think this was just really literally the air. He was in Australia. And this is the pulse red laser coming in here. Now, the particle is in here somewhere, and there's a bunch of them, not just one. And it's coming through here, and everybody else here has got to get out of the way. So they glow like crazy, see them? They're all glowing, saying, all right, I'll get out of the way. And this says, you better get out of the way, I'm coming through. So they all glow, and they move out of the way. Wave, particle. All right, now let's take a look at the green. Same thing with the green. You see it? This one here is getting ready to flip. The bottom here is charging up, and you can see it's getting really charged, and it will flip to the back, and then the one at the back will come to the front to charge up. So that's called a muon wobble. Now, why is this different than the red? What makes it different? It's green, but so what? It's all light. Light's supposed to travel at the same speed, right? They all travel at the same speed. Well, maybe. All right, you see this? This is the green, straight up and down, even though it's going in this direction. Normally you would think it would turn this way and just go straight forward. All right, because the other one was perfectly flat going straight across. All right, now, so you could look at it two different ways, but I can tell you what, this is polarized towards the Earth, straight up and down, and that, the red one came straight up and down, but it just happened to be that it was on that plane already. The other one, the green, was going this way, but the particle stayed straight up and down this way, if you understand what I'm talking about. That's the polarity to the Earth, up spin and down spin. Now, like I said before, what's the difference between the red and the green? They look the same to me. All right, this is very, very, very cool. Now, they talk about light being a wave that flaps like this and so forth. No, it spins, and it spins in a circle. Now, this proves it. This is red. Red is a lot slower than the green, and I can prove that. And it spins in this direction right here. This is nothing more than a drill bit. You see how it's curved? All these edges are curved like this. It's spinning around the circle. It's not just spreading out, flapping like waves. It's spinning in a circle. And the green does exactly the same thing. All right, so here's the green. The green, it's spinning. It's harder to see this, but it spins in a circle. Same thing, coming through the slit. And that's basically the particle trailing off. I mean, this stuff is, what Rodney did, I just can't even imagine. I'm telling you, I know for a fact, he must have spent thousands of hours doing these experiments, because he would inundate me with pictures, and then I would sift through them for days. You know, it was a lot of fun, I can tell you, because I was finding things, and I'm going to show you some things that nobody can explain. And I can explain it. All right, here. Remember I said the red and the green was the difference? Well, here's the difference right here. This is the red coming through. You see how dull it looks? And it's just getting pushed out of the way. Here's the green coming through. That's powerful. It's just pushed that red right out of the way. And the green comes in, and it concusses with the interference of the red, which is making a little bit of a fluff. So it has to hit it. So you see it concussing here. Otherwise, you wouldn't see it till way out here. It's so powerful that it doesn't hit anything of any substance until it gets way away and starts to slow down a little bit. It's just too fast for things. This is just slow, so it hits everything. Now, are they going at the same physical speed and distance at the same time? In other words, 1 second this thing goes from over here to over here, and this only goes from here to here? Or does they both go from here to here at the same time? I say no. I say this one is not going to make it as fast as this one. This one's just got much more energy. I think that when they're taking light and measuring the light, it's white light, which is all the frequencies together, the red, the green, and the blue. That's my impression right now. I'd like to see them show me that these things are not traveling different speeds. I can tell you there's no question whatsoever. They're spinning different spins. And the blue is much faster than either of these. And I would imagine the blue may be going ahead of these. In other words, this is slowest, red, a little faster, and much faster for the blue. And then once you get way up into the ultraviolet, it's called the ultraviolet catastrophe, you lose all of the glowy parts, and then all you have is the big bombers, the heavy particles that will kill you. Now, and that's at the ultraviolet catastrophe. That happens right about up here. Way out into the ultraviolet, somewhere up here. And then all you got left is X-rays and gamma rays. Those are ionizing destroyers. UV, it's not good, but it's certainly nothing like this. Okay, now, so where are we now, Roger? Let's see. All right, here's another one from Rodney. This is the blue coming in through the Venturi, and it's sizzling fast here. It starts slowing down. You would never even notice two particles attached. Each one of these is two particles. Out here you can see them. See them broken off to two parts? And you can see that it's spinning to the right, which means it would drift to the left. This is one picture of the whole thing at once, that snippet of the photon. And we're using CMOS, and CERN uses CMOS to see their particles too. So, you know, we saw it long ago. They just upgraded to CMOS 2 years ago, I guess. And it's working for them. They're seeing them much better than they did before. Plus, CMOS, you don't interfere with anything. CMOS, all you do is you stand off way over here, and it hits the cell phone. It's all it was a cell phone. This is what we took these pictures with. And all it is otherwise it would just go by on somewhere, who knows where. But normally they were putting stuff in, or they were shining lights in, or they were putting little magnetic receivers in there, and they're just destroying everything inside. They call it the observer effect. And as a matter of fact, Don Lincoln talks about it. The closer you look at it, the more it glows or something. No, the more energy they push into it to look at it, the more it glows. Yeah, I can go along with that. But just because you're looking at it doesn't mean it glows more. Now check this out. I told you blue is powerful. That's blue through the air. This is blue through glass. Look at that. There's a little bubble going all the way down through, disrupting whatever molecules are in the glass, which are silicon dioxide primarily, SiO2. And silicon is, well, I don't want to make any statements that aren't, I don't really know, but I can tell you what, they're interacting with the particle beam, obviously. And when they do, anytime you have push to shove, I call it push to shove. If you're pushing something and shoving back, you are going to get a glow. No question whatsoever. 100% of the time. 100%. And that really, my friends, is what energy is push to shove. Oh, this is going to be the killer roundup. This one is just the pulse red laser, pushing and shoving everybody out of the way, and it is the strong guy, so it glows the most, and everybody else got to get out of the way. So we understand that, right? Yes, you do. Now, what happens when we set it through a Venturi? This is fully understood. A Venturi accelerates the particles that go through it. Normally, it's water or some kind of vapor. This light is nothing more than just basically it's atomic vapor, which is nothing more than water almost. So what it does is it accelerates like crazy, and then when it hit here, the particles could not get through the slit together. They just couldn't make it. The black ones were too big, and the slit was too small. And the black ones cannot change their size. So they bang, 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 and squirted the white, because the white can remove itself and go, and it can get small and get big. It went through there as showers. Those are showers. And the energy was so strong coming back, do you have all this glow? That is energy. There's no question whatsoever. It's energy. You just look it up. Nobody can deny that whatsoever. It started out with very little energy, and we increased it to extremely high amounts of energy. Plus, we stripped the white from the black. That's the key. If we can just harvest that white, that's what you put in your car. There's no weight here whatsoever. None. Zero. And all of that white could go into your car and make your car run. Now this is one tiny little laser. Look at the amount of white coming out of there. Is that a lot? I don't know. When they make an engine run, a generator run, they're forcing fields to force other fields to push and rip away electrons. It's a field against field. And you can tell that quite easily if you have a generator. You start it up, and it's running to make sure it's fairly warm, and then you kick in your circuits, and what you're going to hear is the thing will go. What it's doing is pushing, and it's moving those electrons out of that other coil of wires and pushing it down into your circuits, so that you can use that as electricity. Here, we're just stripping it off by not allowing it to come through. Now, if we could harvest it right there, we are golden. Let me just show you something. This is the muon neutrino, and that's a sterile muon. With a muon neutrino is normally attached to an electron neutrino. The two of them together make a Dirac neutrino. Well, when the muon goes sterile, the electron goes into showers, and that is precisely what we had happen here. The black ball went sterile. Before it was attached to the white, remember? And here we have nothing but white showers. And then they come back right over here. That's fission because we broke them apart. There's no question it's fission. Here we have raw white electrons, and I think if we could harvest it here, we'd be pretty good shape. And here it's fusion back together. The black and the white come right back together as Higgs fields. I can show you all of that happening right now. All right, so again, it came through here. All right, and this is just a very close-up of this event. So we accelerated. No question it's acceleration. Nobody can deny this. And then nobody can deny that the black separated from the white. And nobody can deny that they were originally attached. All right, that's what they were originally like. And the green does the same thing. And going through the same slit at the same time, the green interacts with the red and actually pushes the red and spins it this way instead of spinning this way, which it always, always, always does. This, you will never ever see this again in your entire life. You see the way that particle is spinning? They're spinning like little donuts. And that's because this green, in my mind, has to be going faster than the red, saying, get out of the way. So the red, instead of spinning it with its normal spin, let me come back here a little bit, which is going to be like this, oriented to the earth. It's now tumbling. It pushed that field. Field to field is going to push. It's going to push. So this field must be pushing faster than that field. It's spinning faster, I would say. I would imagine its spin is faster. Now, when I say spin, what do I mean by that? This is, let's say this right here is red. And if you look at it from the side, you'd say that's a wave. All right, it looks like a wave, but it's not. It's a spin. All right, so red is way over here. It's going slow. While the green is back down here. So is it just going too fast and hitting it because it's so much shorter of a wavelength? Or is it just going too fast because it's going fast? I don't know. Je ne sais pas. I do not know. But I do know that the green is much more powerful than red. This is fully understood. And even with a Crookes radiometer, you can see that there's different levels of light have different intensities and power. And the white is the best because you got all the frequencies at once together, all the way up. But blue is very good and powerful too. So there's a lot of nuance in light. But I'm going to tell you right now, that green is much, much stronger than that. And that's just phenomenal, the way that thing is spinning. That's just, you never see that. Not one other experiment. But we did find, well, where did I see it? I'm going to show you this thing and I'm going to knock your socks off. All right, this is the easy way to understand this. We know those are the particles. So we had the wave, and then it's accelerated, and then coming out here, these are what's coming out. See this here? This is like we're looking into here. So we're looking into that right there, and we're seeing all these, what they call Higgs fields. And one of them came out very, very strange. The only time I've ever seen it. And I've seen trillions of these. All right, Higgs fields are these circular patterns like this. Now, again, CERN and Fermilab use particles. They make all this debris, just crazy, crazy debris, because they're working with particles thousands of times bigger than ours. Thousands and thousands of times bigger. They smash these particles together here, and they just get tons of debris. Sometimes they get exactly what we get. They get photons, and they can see the little particles, but they can't put it all together. Here's what happens. Instead of using light, which we use down in this range, you're never going to get much bigger than this. It's not going to get bigger than that at all. Now, they take huge things like this, much, 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 much bigger, and they smash them together, and they get all this debris flying everywhere. Well, occasionally they'll get one or two that are tiny, and then they get all thrilled because we see a tiniest, well, we saw another one, and then they spend years and put all this database together, and I say, yep, we see a lot of those. So we notice some of these little blue ones, we notice some of the little green ones, we notice some of the little red ones, and then we notice some photons. All the rest is just nonsense. This X means just a chunk like this, because they're big particles, and the people that work there have to be careful because they are getting irradiated all day long by these huge particles. They can only stay so long near them. All right, so you've seen CERN and Fermilab. They get these big, huge smashes when they hit these things together. They just get all this stuff. They see the Higgs fields, but they're just seeing a bunch of debris. And once they found these Higgs fields, they were really thrilled. All right, so where do Higgs fields come from? They come from a concussion of fields. When they smash these things together, they get Higgs fields, yes, like this. We crush ours into a venturi. So when that happens, we get Higgs fields too. We get the same Higgs fields, only we get them directed exactly where we want them. You see this? It comes down, and once it comes out of here, when they reform right out here, they turn into the Higgs fields. Right here, there's nothing. Right here, there's just whiteness. And I can show you looking into this. Get ready. Here it comes. We're going to look directly into that venturi. And here it is right here. You see that? We're looking directly in. There's nothing here. There's no whiteness. There's no nothing. However, as soon as the white can hit the black particles, they turn into these fields. You see these little spritzes coming out of everywhere? As soon as they hit a black one, they just start spinning. That's what it appears to me. And I'm almost certain that that's true. Now, this one right here, here's the key. Let me turn the lights off so we can see a little better. That little white one is spinning backwards. They're all supposed to spin to the right-hand rule. I believe it's the right-hand rule. Now, this one here is spinning backwards, and I believe it's real bright white because it's gathering a field into itself. These are sort of like throwing a field out. Something along those lines. That's the best I can do with that. But this is coming directly at us, and these little spritzes, you see them when they hit these particles, they start them spinning. Now, what happened to that particle? Well, that's a good question. All right. I claim these Higgs are spinning fields, and I claim they spin this way. All right, so this one here is spinning this way as well. This was the backwards particle. I'm pretty sure of this. All right, I didn't do this experiment, and Rod just sends me these pictures and stuff. Well, he doesn't do it anymore, but he did. And I worked on this I couldn't figure this out for a long time, but I got it figured out now. This is that reverse spinner that was turning white amongst these normal fields, if you remember that. It's spinning this direction. Everybody else spinning this direction. So this one's spinning backwards. And what would happen? The outside particle, I believe the particle itself, sits in the outside ring, and it forces this fields to converge inward to create this Higgs pattern. But the particle itself, I believe, is in the outside ring. That's my thinking now. So what would happen? This one's going this way. It still has a particle, it's just going backwards. And it went this way, and it collided with this one going this way. So what happened is the particle, instead of staying with this field, was ripped off by this. So this one's coming this way. And that one hit it, and it tumbled it right off, and it's tumbling this way. You see how energetic that is? Energetic. This is a concussion. That's a concussion of fields. And this one here is stripping that particle off. Because by now, it should be a particle. It should be a black and a white together. That's what I would take. Anytime you see a Higgs field, it's got both particles together. That's my feeling. And the Higgs fields come in and they come out the other side. They're not just on one side. If you recall this, look, this looks like a Higgs field to me. That looks like a Higgs field. That looks like a Higgs field. That's coming in. And then they get crushed, and then they come out the other side. They still look like Higgs field coming out the other side. To me, what do you see? I see almost exactly the same thing. That's coming out. That's not going in. Look at this. This is Higgs on steroids, I call it. Look at that. That's the white coming through. Really confined. You can see some black. You see the little black particles will come. You can't really filter out all the black, but most of it. Almost all of it. And I'll show you another one that's stunning. Now you see these little white spritzes coming off of here? They're very hard to follow, but this particular one is about the best I could have ever found. And here it is right here. You see it coming off here? And bang. At this point, it starts to form its field. Now, because it's not going any further. You see, it's white. So it banged into another black particle or something here. I don't know. All right, don't forget, you can't see the black particles. The only time you see the black particles is when they're on top of the white. All right, otherwise you don't see them. They're all over here. There's black particles everywhere, but they're not on top of the white. Once they're on top of the white, you can see them. It's like this right here. Well, wait to see this. Hold on. This is so cool. This is the Venturi tuned. Unbelievable. The light is coming this way. The Venturi is tuned to a point where quite a bit of the black can get through with the white, but primarily the white. All right. And here it is coming out the other side. Look at this. And the black is pushing the white ahead of it. All right, so we know that the black is the pusher or the carrier. Now, if the black was way back here and the white was up here, the white would come back towards it. The white only wants to be with the black, but the black can push the white. The white really has it doesn't go anywhere by itself. It doesn't go anywhere by itself. But when an atomic bomb goes off, it has exactly the same properties. The atomic bomb goes off, all the white goes first, and then the black comes. And the white has no mass. So what would you expect to happen if something of this white magnitude hit, like a building was right here, and it had no mass at all? Well, the building wouldn't move. You don't have any mass, you can't push it. So the building would just stay there. But this has so much energy that the building would burn up. I know it sounds crazy, but it would. The building would just sizzle like this and smoke up, and it wouldn't move. But then the black would come, which is all the heavy stuff, which is pushing this, and it would hit the house and knock it down. Let's take a look at that happening. Okay, get ready. This is Atom Central. This is the atomic bomb blast. Now, I just stopped it. The atomic bomb has just gone off, and this is a test house. Now, this goes way back to when they started testing nuclear bombs to see what kind of destruction they would have. Now, I worked in this, not specifically with atomic bombs, but I worked missile sites, atomic missile sites when I was in the Army. And I took a great interest in this sort of stuff. But right now, you see this house hasn't moved. You see everything's glowing? And what I want you to pay attention to is just everything smokes up, not even really pushing it at all. All of these poles and all of the wires and everything are absorbing this white particles, but they have no mass. They don't move anything. Think about this very carefully now. Nothing's moving. It's just burning. It's burning, 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 burning. All right, now keep your eye on it. Look. All of this is burning up, and the shingles are almost completely burnt. All of the wires are up here are just smoking up. They're not pushing. Nothing's going that way. How could that be? No mass, all energy. Think about that. How do you account for that? I can't. All right, it's just smoke, smoke, smoke. Now, in a second, the black particles will hit. Remember I showed you the white was coming out a big bar of white like that, and then all of a sudden the black hit. Well, the same thing's happening right here. That was a white bar, now coming to black, and it's just going to go smash into bits. Boom, you see that? I ripped the shreds out of it, because now that's the one with all the weight. The black has all the weight. And then it will turn around and come back, because there's a void back here. And nature abhors a void. You see, it all turns around and comes back. All right, that's what happens in an atomic bomb blast, because the white surrounds the black, and the white goes out first. Simple as that. So we got a few changes to do. We got some chemistry and, the isotopes and things like that, half-life. So we got to really look into enzymes and all that. Space, we got some real situations going on there. Redshift, forget about that. That doesn't work. It's saturated. Space is absolutely saturated with particles. Space-time distances, all that stuff is really crazy. There's no way for them to measure the distance from here to anywhere. Whatever field they have to go through, it's going to slow down the light. It doesn't just go the same speed every time. That's why Einstein destroyed science, literally destroyed science. Everybody's, oh, no, you can't say that because Einstein says this. I don't care what he said. He was wrong. That's as simple as that. All right, let me sum this up. The white particles have no weight in all the energy. They burn things. The unknown particle they never knew about was the black particles attached to the white. It was always unknown. It was never seen until now. Now the black carries and pushes and pulls the white. So the black is a pusher, and if it's just stagnant and there's some extra white, zip, they will go to it. So it's gravity, basically. So the black carries, pushes, and pulls the white. Therefore, black is dark, which we know it's dark, and it is matter because it has the mass, so it's dark matter. Black pushes the white, therefore it's dark energy. The black is the energy, it pushes the white. The black pulls the white, therefore it's gravity. The black is all those things. It's dark matter, it's dark energy, and it is gravity. All the things they've lost, they couldn't find, is because they're attached to the particles of light. And they never knew that. They just didn't realize it. So the black pulls the white, it's gravity. And because all matter has white surrounding the black, they all come to the earth. Because the earth is saturated with dark matter. It's earth ground. All electricity will try to get to ground. Anything you have is electricity, you know that. Lightning, bzzz, static, snap, right to ground. Electricity, right to ground. And you could be holding that wire and it'll go right through you to get to ground and you're dead. So it desperately seeks ground, and ground is the dark matter. There's much more dark matter in the earth than there is white matter. And the reason is the earth itself, the mass of the earth is primarily less heat than the surrounding atmosphere, and that means less heat means less electrons. So that gets a little complicated, but don't worry about it. Now, white is the white part is all the glow. This white is all the glow. That's it. No mass, just glows, burns things up. White seeks the black strongly. So that black will just come to that white through anything, through motors, through resistors, through heating coils, through your body, anything to get to that black. Now, the white alone is electricity. When it's just the white, it's electricity. That's why when you put electricity in your car to charge it up, it doesn't change the weight. There's no weight. So the white alone is literally electricity. Now, here's the deal with the different particles. You can have the white and the black. You can have the white a little bit bigger than the black, or the same size. You can have it a little bitty tiny, and the black never changes. The black never changes because it's fixed. You can have that thing go huge. All right? And it weighs approximately 0.00054,854 atomic mass units. The point particle weighs nothing that I can find. And there's approximately 1823 to 1840 electrons that make up a proton. And I take that because of Millikan's oil drop experiment, which he says around 1840. I somehow came up with 1823, and I got to be honest with you, I can't remember why I focused in on that number. But 1823 in my world is a proton, and 1824, which means this even number, is a neutron. And that makes everything account for isotopes and half-lives and enzymes and catalysts and all the things that happen that they can't account for. And it also accounts for dark matter, dark energy, gravity, the solar corona, the Earth's atmosphere, global warming basically, and everything else. There's nothing I can't explain with dipole electron flow theory. Nothing. Absolutely 100% I can explain. Anything that you can present to me, I can explain using dipole electron flow theory. And these are the only two particles that exist. It's a black one and a white one. And when they're on their cells, that would be what you call normally an electron, and it would go in as heat. But when you just have the white all by itself, it's electricity. An electron contains the two of them together, and it's primarily heat and so forth. And it attaches to things. It always wants to be attached to something as an electron. Now, if you separate them, you really got to pull them apart, and that does it. The Venturi separates and pulls them apart. They say that it takes literally almost a ton of energy to rip these particles apart and push the white into a battery. So you're using mechanical energy a lot, these windmills and water wheels and, motor generators. So you're always using a lot of energy. Plus, you can't walk around with them. If you see what I just showed you, if this would work, and I'm not saying it will, I don't know. I think it will. I don't see why it won't. What we want is that white, and that white has no energy, no weight to it. And if we can fill up a battery or just plug in anything we want, we could take those things like that right there. You take something like that and walk around with it. All right, you dial in anything you want, any AC, DC, USB, 50 cycles, 60 cycles, 110, 220, whatever you want. And you could have literally thousands and thousands of those lasers and receivers inside here. They're tiny. So I don't know. This is a research project. I'm not going to do it. I'm done with this stuff. I got to be honest with you. It was very discouraging that no matter what you do, there's no interest, and it's pushed back. It's not, Don Lincoln to have shown these particles and tell me that I'm a tinfoil hat guy because I'm saying I'm working with light, which is much smaller than the particles you're working with, and we are seeing the particles that you found because you smashed yours to bits, and you can see those particles. We haven't started with them. We're way ahead of these guys. We're way ahead of them. They're thrilled when they see a Higgs field. We have them coming out of our ears.